we are given the function f defined from r squared to r, where f of x and y is equal to x squared times y plus 2x. We are asked to calculate the directional derivative in the direction of the vector minus 1, 1 of the function f in 1, 0. This can be done in different ways. We are going to use the definition. It says that the directional derivative in the direction minus 1, 1 of f in 1, 0 is equal to the limit when t approaches 0 of f of 1, 0 plus t times minus 1, 1 minus f of 1, 0 divided by t. This is equal to the limit when t approaches 0 of, here we have an operation of 1, 0 plus t times minus 1, 1. This would be 1, 0 plus t times minus 1, 1 equals 1, 0 plus minus t. T equals 1 minus t, t. So in the numerator we would have f of 1 minus t, t minus f of 1, 0 divided by t, and this would be equal to the limit when x approaches 0 of, first let's calculate the elements we have on the numerator. So f of 1 minus t, this would be x and this would be y, and we just have to substitute them in f of x, y, where x appears 1 minus t, and where there's a y, just a t. So we would have 1 minus t squared times t plus 2 times 1 minus t. Doing the square, we have the square for subtraction would be the first element square, 1 minus 2 times the first times the second element minus 2t plus the second element square, t square, everything times t plus 2 minus 2t. This is equal to t minus 2t square plus t cube plus 2 minus 2t. This is equal to t cube minus 2t square minus t plus 2. So substitute in the limit t cube minus 2t square minus t plus 2. Now minus f of 1, 0, let's calculate it down here. Where x appears, let's write a 1, and when there's a y, a 0. So this would be 1 squared times 0 plus 2 times 1 equals 2. So in the limit again, we would have a minus 2, and the denominator is t. We have the limit when t approaches 0 of t cube minus 2t squared minus t divided by t equals the limit when x approaches 0 of t is a common factor, So t squared minus 2t minus 1 divided by t. We can simplify the t's, and this would be the limit when t approaches 0 of t squared minus 2t minus 1. Now we just have to substitute the 0 where there's a t. So we would have 0 squared minus 2 times 0 minus 1, which is equal to minus 1. So this would be the result of the directional derivative of f in the direction of the vector minus 1, 0 in 1, 0. It would be minus 1.